Welcome back to The Explainer. Today, we're embarking on a truly fascinating journey. We're tackling a highly conceptual topic, so I want you to get comfortable, and we're going to take this nice and slow. We are going to explore the invisible bridge between human language and machine intelligence. We're talking about how AI actually understands meaning in text. To start off, let's rewind just a little bit. In the last explainer, we saw how vector databases help AI search using meaning instead of keywords. We learned that this is incredibly powerful because it frees us from just matching exact text.
But this creates a much deeper question. How does AI actually represent meaning in the first place? Really think about that for a second. Well, here's the core problem we have to face. Computers do not understand language the way you and I do. They are machines. They literally only understand numbers. They don't have a human brain to know what happy feels like. They don't intuitively know what a login error means in the context of a stressful workday, or what a restaurant recommendation implies for a fun Friday night out. They have absolutely zero human context. Because of that, we arrive at this foundational rule. AI must convert words into numbers to process them. I'm going to say that one more time so it really sinks in. AI must convert words into numbers, and that is exactly where today's core concept comes in. We call this process creating embeddings. Embeddings are a way to convert text into meaning, represented as numbers. It's basically the translation layer between our messy, emotional human language and the strict mathematical world of a computer. To put it even more simply, embeddings are not just words translated into numbers. They are meaning captured as numbers. These numbers represent the context, the intent, the similarity, and the relationships behind the words we use. Section 1. The restaurant analogy. Taste profiles versus dish names. Okay, let's dive into this, because the absolute best way to really grasp this is to step into the physical world. Imagine you're sitting in a restaurant looking at a menu. Think about the raw words, the dish names. You might see spicy chicken burger and a hot grilled chicken sandwich. Those are completely different words, but underneath those words is the actual taste profile, the spice level, the texture, the feeling of eating it. You don't just order by the names, you care about the taste. Even though the names are different, the underlying meaning or taste is incredibly similar. And that underlying taste profile, that is exactly what an embedding is. Now, I want you to visualize something for me. Imagine a vast, three-dimensional map where similar ideas are placed close together in physical space. Got that picture in your head? Now, what's really interesting about this is how that map works in practice. Sentences are basically just points in this mapped space. Take the phrases "I cannot log in" and "sign in failed." In our meaning space, these 2 points are clustered very tightly together because the context is almost identical. But then take completely different phrases like "I love pizza" and "weather is nice today." These sit far, far away from the login issues and completely far away from each other. So how does this actually happen? Well, it happens in 4 simple steps. First, the input text, say, "My internet is not working," is given to the AI. Second, the AI converts that text into a long list of numbers, a numerical representation. Third, this numerical representation, which captures meaning and context, is placed into that vast meaning space we just visualized. And fourth, the AI compares it to other points in that space to see what it sits closest to. It'll instantly find things like network issues or Wi-Fi problems sitting right next door. Which brings us to a truly fascinating question. How does a machine know that 2 sentences are similar even if the words are completely different? It knows because it's mapped the variations. You see, humans don't always use the exact same words to describe the same problem. One user might say there's a bug in the system. Another might say there's an error in the app. A third might just yell that the app is crashing. They all mean the exact same thing. Embeddings empower the AI to understand this underlying similarity without getting tripped up by our messy vocabulary. So the crucial point is, embeddings are not about words. They are about meaning relationships. They measure the distance between concepts, not the letters on the page. Section 2. Embeddings in the real world. Let's move to and see how this builds into the technology you use every single day. Because this isn't just theory, this is the engine of the modern internet. This exact taste map technology is what powers the most popular AI systems in the world right now. When Google gives you a highly relevant search result, even if you typed the query weirdly, that's embeddings. When Netflix or YouTube recommends a video that perfectly matches your current mood, that's embeddings plotting your preferences in meaning space. ChatGPT understanding your prompts, and GitHub Copilot understanding your code, it all relies on this system to understand similarity. And this brilliantly illustrates our core mental model for today. Words are really just raw text. But embeddings? Embeddings are meaning coordinates. AI doesn't read words, it reads meaning positions. And this completely closes the loop with our previous explainer. Remember those vector databases we talked about? Well, embeddings are exactly what vector databases store and search. Embeddings create the meaning points, the database stores those points, and the AI searches through them using similarity. They're literally two halves of the exact same system. Now, before we wrap up, I want to clarify one very important boundary about this technology. Embeddings do not understand meaning like humans do. There is no conscious thought or emotion happening inside the machine. What they are doing is exceptionally good math. They are mathematically measuring the similarity between ideas. And as it turns out, measuring similarity accurately is enough to create incredibly powerful AI systems. But this leaves us with a bit of a mystery. If AI can convert text into meaning, store it as numbers, and retrieve it so perfectly, why does it sometimes completely forget earlier parts of a conversation you were just having with it? What is actually happening behind the scenes when an AI loses its train of thought? We are going to unpack that exact mystery in our next explainer on AI memory and context windows. You absolutely won't want to miss it.